All right, question number 9. The shape of the distribution of the time required to get an oil change at a 20-minute oil change facility is skewed right. However, records indicate that the mean time is 21.3 and the standard deviation is 4.6. We're going to complete parts A through C. All right, so we are given the mean is 21.3 and the standard deviation is 4.6, and we were told that this is skewed to the right. Part A, compute probabilities regarding the sample mean using the normal model. What size sample would be required? So we were told the central limit theorem part wants to say 30. So normal cannot be used if the shape is skewed to the right. Sample size needs to be less than 30. Sample size needs to be greater than 30. Any sample size could be used. So we want to go with C. We need at least 30 or more. That was our rule of thumb. What is the probability that a random sample of n equals 40 results in a mean less than 20 minutes? Okay, I'm sorry, I got that off screen. So part B, mean less than 20 minutes. And I'm just going to do this whole thing using the table. So probability that this is going to be less than 20. All right, so we're going to just start here. We're going to apply the mean formula, sigma divided by the square root of n. So I'm going to apply this to this, and it's going to convert to a z. So probability x bar minus mean over standard deviation divided by square root of n. On this side, I'm going to actually change it to the numbers. So we started with 20. That was my x bar. And then we're going to subtract the mean, which was 21.3, divided by standard deviation over the square root of n. Standard deviation is 4.6 over the square root of n, and we were given that n was 40 in this problem. So once you apply this, this is going to convert it to a z less than, and we're going to figure out what this number is. Okay. So calculator. I'm going to do 20 minus 21.3, and then we're going to divide that by the 4.6, which is also divided by square root of 40. Actually, let me go back and delete that. Get outside and tell it I'm done. Okay, this is going to give me my z value. So I'm looking at negative 1.78, which will round up to 1.79. So I'm looking at negative 1.79. So if I was to draw my bell curve, negative 1.79 is going to be on the left, and I'm looking for the area less than negative 1.79. Okay, so standard normal, we're going to go down to 1.7, and this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It'll be this last one. So that's 0.0367, 0.0367. And then part C, suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. On a typical Saturday, the oil change facility will perform 40 oil changes between 10 a.m. and 12 p.m. Treating this as a random sample, at what mean oil change time would there be a 10% chance of being at or below? So this will be the goal established by the manager. So we want to be at or below being able to do 40% oil changes. If there's a 10% chance, so we're looking for the probability. We're gonna work backwards. We're gonna find Z first. So we're looking for a probability that our Z is going to be at or below, less than or equal to some number. Is going to be equal to 10%. So we're looking for this area right here to be 0.1000. So I'm going to find that Z value, work backwards, and then find the mean. So Z chart, looking for 10% in the middle. Okay, so right here, this row and column, can't tell what row we're on. 1.2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 1.28. Okay, so we are looking at this Z value being a negative 1.28. All right, so now that we have that, I'm just going to say that that is equal to X bar. That's the number that we're looking for, minus the mean. The mean is going to be the same, 21.3. Standard deviation is 4.6 divided by the sample size, and it said that we're going to do 40 oil changes. So we're going to work backwards. We're going to multiply by the standard deviation and then add this to find the sample mean time that we would need to make that happen. So negative 1.28 times this standard deviation, 4.6, over the square root of 40, and then we're going to add the 21, so plus the 21.3. That's going to give us our sample mean that we need to hit those numbers. So we're going to do negative 1.28 times 4.6 divided by the square root of 40. And then we're going to add the 21.3. And we get a sample mean of 20.36, and we want to round to one decimal place, so 20.4.